Hi everyone, my name is Nasibullah and I'm going to present our work Thinking Hallucination for Video Captioning. This is a joint work with Parthaprati Mohanto at UCSU Unit, Indian Statistical Institute, Kolkata. Video captioning task is the generation of natural language description of a short video. It has several applications ranging from video retrieval, assisting visually challenged people, human-computer interface, and many more. Despite the applications, there are several challenges. One of the main challenges is the additional temporal information and complex motion patterns. Another challenge is the evaluation metric for video captioning is not properly aligned with the training signal. The most common approach in video captioning is the encoder-decoder based sequence-to-sequence architecture. The recent improvement in video captioning models has happened in broadly three areas. Better visual feature extraction, where along with the appearance features, recent methods uses motion features and object features. For example, STG-KD, proposed by Pan et al., uses spatiotemporal graph neural network to model the object interaction features. Another area of improvement is the use of better language models and support of external pre-trained language models. For example, ORG-TRL, proposed by Ziki et al., uses BART language model which guides the decoder language model in a teacher-recommended learning settings. The third area of improvement has happened in improved sampling strategy for informative frames. PicNet uses reward-based objective function to choose the informative frames, whereas SGN uses partially decoded information at the decoder to select the informative frames at the encoder. In this work, we focused on video captioning models from a different perspective. We try to understand the hallucination nature of video captioning models. Hallucination is a phenomenon observed in natural language generation where the target description is detached from the source information. For example, in video captioning, the generated caption might contain objects or actions which may not be present in the video. Hallucination nature is observed in natural language generation tasks such as neural machine translation and image captioning. To name few of the previous methods, Cohen et al. Mentioned that hallucination is one of the 6 challenges for machine translation, whereas Lee et al. Proposed that neural machine translation models hallucinate under source perturbation. More related work to our is done by Anna et al., which discuss object hallucination for image captioning. The authors also proposed a way to measure the hallucination for image captioning models. Another way to understand the hallucination for video captioning is looking at the experiments done by us. So we have plotted the confidence of the model at different token position, and we can see that the model's confidence is low towards the middle of the caption. As a matter of fact, for the experimental datasets, the object words and the action words also occurs towards the center of the caption. For video captioning, there are 2 types of hallucination: object hallucination and action hallucination. This can be seen from the figure beside. So the top figure shows the example of object hallucination where the existing method generate caption as a man is riding a horse. Actually, it should be a bike. So we can see an example of object hallucination. Similarly, the below figure shows the example of action hallucination. We summarize 3 major sources for hallucination in case of video captioning: inadequate visual features extracted from pre-trained models, improper influence of source and target context during intra and intermodal fusion, and exposure bias in training strategy, which is already established in the literature. In summary, we identify the main sources of hallucination for video captioning. Then we propose two robust and simple solutions to mitigate that. We use auxiliary heads on top of the extracted appearance, motion, and object features to fine-tune them. We also use the context gates to balance the influence during intermodal and intermodal fusion. Finally, we proposed the COA metric, which is a way to measure the degree of hallucination for video captioning. Our proposed architecture contains four main components: visual encoder, which extracts different appearance, motion, and object features; auxiliary heads, which fine-tunes the extracted visual features; intramodal and intermodal context gates to balance the influence of the context during fusion; attention-based decoder. To be noted here that the parametric context gates are conditioned on a separate visual and language memory. Let's describe each proposed component in more details. Fine-tuning different backbones together is extremely difficult, and which leads to inadequate features and hallucination. We use auxiliary heads, object, category, and action heads, which uses to fine-tune the different features expected from different backbones. This idea generalizes the work done by Pan et al., which uses semantic attribute to fine-tune the appearance features. Here is an example of action heads where we can see the motion features are as the input, and it is given to a action head and which is trained in a multi-level objective settings. The ground truth is generated from the caption itself using the name entity recognition and part of speech tagging. In video captioning, there are two types of fusion: intermodal fusion and intermodal fusion. In intramodal fusion, different visual features are combined. One feature might dominate other, which leads to hallucination. For example, motion features dominate appearance and object leads to object hallucination. We use intramodal context gates to mitigate this and dynamically select the feature importance. Similarly, during intermodal fusion, dominant language prior leads to hallucination, and this is tackled by intermodal context gates. We propose COA metric, which stands for Caption Object and Action Hallucination Assessment. This is a metric to measure the amount of hallucination. Our proposed metric considers object hallucination and action hallucination. The COA metric is defined per instance and is a summation of OH, which is object hallucination, and AH, which is action hallucination. OH is defined as the average semantic similarity of the predicted hallucinated object word with the ground truth object word. Our proposed metric considers the semantics into account. This is the quantitative results where we evaluate our method on MSVD and MSRVDT dataset. We have compared our method with the existing ones, and we can see that our method has improved performance, especially in CIDR metric. In qualitative results, we can see that our method has performed well in cases where the existing method fails during hallucination. To understand the importance of proposed component, we have done ablation studies where we started with the vanilla version and we have sequentially added each component and evaluated the hallucination measure, the COA metric, as well as the caption performance. So we can see from the table that the addition of the proposed component has indeed improved the performance in caption as well as COA metric. We have also shown the significance of context gate in intermodal fusion. So we can see the value of the source gate is high during the generation of visual words, and in case of the generation of non-visual words, the value of the target gate is high. To understand the semantic significance of our proposed metric, we have shown some of the examples here. where the first caption, a man is riding a motorcycle, is a ground truth caption, and we can see two different predicted versions of this caption, which is a man is riding a horse and a man is riding a car. In both the cases, we can see the presence of object hallucination. However, the third caption, a man is riding a car, which is more similar to the actual ground truth, and we can see the object hallucination is less compared to the other one. So our proposed metric considers the semantics during the measurement of hallucination. Similarly, we can see the case for action hallucination and the combination of both action and object hallucination. Thank you for your attention. If you have any further question, please feel free to contact us. Also, you can look at the project repo in the given link. Thank you.